Hello, so this is part 2 of Hexologic. Let's find where we finished the previous one. Okay, we finished the 67 and we go ahead with this one. So we have 6 here, which means it's 3 and 3 and 1 left, and this one is 9, so we already have 4, so those are 5. Okay, so 5. And we need to keep in mind, okay, let's leave it at that for now. Let 4, this 1, 2. You see we have 5 here, and that means that this is supposed to be 6, because it needs to be more, a greater number. So 3, 3, 1 left, 3 over here, and this is supposed to be 9. So 6, 7, only 2 left. Next one, let's see. We have 12 here, so it's 3 and 3. We also have 11 here, which means that it's 5, minimum of 2, and maximum because of this 3. This means this is 1, so this is 3, and this is 3 as well. Let's see here, it's 6 equals 2 cells, so it's 3 here and here. And also we know that it's 6, 12, so left 3. 2 left, 3 here, 2 here, 1 left. What next? 4 over here, we have 1 left. It doesn't help us much, but still. 7 over here, we have 3, so 4 left. And what else? Okay, so here we can have only 1 or 2. That's fine. Let's say we have 1 over here. We can't have 1 over here. If it's 2, okay, I'm stuck for some reason. 1 second. So this is 3. So this can be either 1 or 2. Okay, so at maximum this is 2. That means that at minimum this is 2. So this is 2 actually. So this is 1. So here's 2 and 1. Yeah. Next. So this is 2. 3, 1, 2, 2, 2, 2 here. We have a freebie here as well. And since it's something bigger than 2, then it's 3. What else? It's 2 bigger than 1. Okay, let's look at this symbol, for example. So this row, we have on the left side we have 4 plus something, and on the right side we have 3 plus 2 cells. Let's say those will be just ones, then it will be 5, and this is supposed to be at least 6, so at least 2. Okay, doesn't help us that much. It's okay. Let's look more. This is 6, so this is at least 2. This is, so those are 5 combined, and this means this cell is at least 2. So this cell is at max 2. So this one is at least 2 as well. You understand? Because of this 4. So since this is at least 2, then it means that some of those are at least 2 plus 2 plus 1 plus 1, which is 6. So those supposed to be at least 7, and they can only be 7 at max. So this is 3. This is helpful, so we're done with that. And right here we know that it can be more than what we like assign to it. So just 1, 2 here, and then we have 2, 2, and 3, and 3 left here. What's here? So this right side is supposed to be bigger than this left side, and since it's 7, so this from the left side it will be at least 7 plus 2, so 9. So this is supposed to be at least 10. Then it's 10, and of course it's 7 plus 2. And now we have 1 left, we have 3 left here, we have 1 and 1 left here, 2 here, so it's 3 here. Again, this is 7, so nothing to figure out. 2 left here, and this is 3 equals 1 plus 2. Okay, right here we have 3 and 5, so this is 2, this is 1, this is 3. We finish here, here, and here. So this is 2 left, 3, 5, 6, 1 left, and 1 cell is bigger than 2 cells. That means the only way for this to happen is if it is 3 and this is 1 and 1. Let me move my music into my earphones. Okay, next let's consider this. So since something is bigger than 3, it only can be 1 and 1, 2 here. This one is a sum of okay, this one is sum of those two. So since it's 2 and 1, then it can be 3, 1. 3 is bigger than something which is bigger than something else, so it's 2 and 1. 2 left, 2 left. Okay, and we're done. What do we have here? Like 1 is bigger than 2 cells. It means it's 3, and it means it's 2. 1 left here. What else? 2 is bigger than 1 is fine, but they're supposed to be 5. Those 3 cells give us 5. That means that this can be 3. It can be 3. So it's 1 or 2. Okay. Okay, and since this one, since this cell is 2 at most, it means that the remaining 3 cells over here have 2 at most, at least. So those 1, 2, 3, they're at least 2. That's good. Good to know. Okay, let's consider this part. You see that there's a lot of 3's, 2, 2, 3's, and this is combined value of those two. So it can be 1. Okay, let's see if this can be 2. So if this is 2, then this is 3, this is 1, and this is 1. So it can be, again, if this is 2, then this is 1, and this is 2, and this is 2. So you see that 2 equals 2 plus it can be 0. So it's not 2. And it can be 3. So it's 1. Means this is 2, this is 1, and this is 3. So this remainder is 2. We have 2 here as well. 3, 1. Okay. Now let's get back to this 10. Or not. Or not. What we have else? So those are at least 2. But we know for sure that this one can be 3. Because if this one is 3, then this cell won't be correct. It means that it can only be 2, and this will be 3 and 3. Nice. Because it can be 1. If it would have been 1, then 1 plus 2 is 3, and we have 7 left for 2 cells. So, okay. What's next? Let's see. We have 3 over here, 4 here. We know those two give us 3. Okay, interesting here is that this cell is only connected or restricted by this sign, so it easily can be either 1 or 2. Okay, let's say this is 2. If this equals 2, then it will be 2 here, and it will mean 1 here, so it'd be 3 here. Okay. Okay, I don't think there's any restrictions in this side, on this side. So let's look at this part. We have 4. Okay, let's consider this cell. It can be 1, definitely. What if it's 2? If it's 2, then it means that this and this is 1. If this is 1, then this is 3. So it can't happen. Okay, so it's not 2, it's 3. Good. So this is 1. And this for this 3 to be greater than 1 plus something, this something can be only 1. So we have 3 here and 2 here left. So we have 3 over here. We have 3. So okay, it's not that it can be 1. This one can be 1. It can be 3. Why? Why not? It can be 3 because they're like, okay, the sum of those should be 3. So it can be 1, it can be 3, so it's 2. 2 over here, 1 remaining, and 1 here. Okay, next 5 and 3, our bread and butter. So 2 here, 1 here, 3 here. Again, 1 cell is greater than 2 cells, means this will work. Another one, 1 cell equals 2 cells. That will be interesting. Anything else? 3, those two equal 3. Oh, actually, since those sum of those 2 cells equal 3, it means that none of those can be 3 themselves. So at most this cell is 2 and it equals sum of those cells. So 1, 1 and 2, the only way. 1 here. 3 equals something plus 2, so it's 1. And 4 here remains in 3. Good, we filled some of those up. So this is 8 and we have 6 left this way. Okay, and 1 is greater than 1 cell is greater than 2 cells, means it's 3 and 1. 4, 1 remaining, 3 remaining. For this 6 we have 4 already and 2 empty cells, it means they are 1 and 1. And for this one we have 2 remaining. Okay, so we have a cell bigger than this cell, which equals those. It means that this cell, for example, it can't be 3. It can't be 3 because nothing will be greater than 3. At the same time, it can be less than 2 because it equals sum of 2 cells. So the only way to get this is 1, 1, 2 over here and 3 over here. Great. Then we have 4 over here, and this cell is bigger than this one. That means that it can't be 1 because it will be less than 3. It can't be 2 because it will be 2 and 2. So it needs to be 3, and this remainder 1. Here we have 2 remaining, and 1 remaining over here. We don't know much about this cell yet, but those 2 cells are bigger than those 3, and those 3 cells are at least 3 in total. That means that we need to have 3 here and only 1 in each of those. We can put it here as remainers, and something greater than 2 is 3, 1 remaining, 2 remaining. Right here we have 3 because of this 4, so 2. Done. Next one. Okay, we have a new rule. Those kind of shapes, they are counting number of points in the same color, like that. So it's supposed to be 6 in one place. So 3 here and 3 here. Now we need to understand that sum of those blue colors is 3, no matter what. So this will have 3. It means that this is remainder 2, so right here. We have 2, so 1 and 1. So right here we have 8. We already have 2, so we need another 6. To have 6 in this configuration, we need to have 3 over here, so it's 8 now. 1 remaining, and 3, 1, 2, 3. Okay, so 3 and 5. It's always good. Now we have only one orange cell left, and how will it affect us? We have 2 already here and 6 in total. That means that by pressing this one, we add up to 4, and like that we add up to 6. 4, 1 remaining, 4, 1 remaining, 2 remaining. Okay, let's look at those. Since they have the same cell for both of 7 and 9, it means that this cell is supposed to be greater than this cell by 2, which only possible if this is 1 and this is 3. Now this cell needs to be 6, and the only way for it to be 6 is to have both on this and this to have 3. So we have 1 remaining, 2 remaining, and 2 remaining. Okay, What else? What else? Oh, this 7 is very long. It has 6 cells and only 7 in total, and we have 5 here, so this is at least 2, means it's 2, and every other one is 1. So 3 here, 3 over here, 1 here. Okay, this one's supposed to be 3, means that this will be 3 as well. So this will be 2, and it needs to be 3, and we have 1 cell empty, so this is 1. And there will be no more orange dots, so this is remainder 2, remain 3, and remains 1. Okay, here we have how should we look at that? Okay, so this is 2 at most, and those give us 3 combined. Because those are 3, that means that this is at least 3. And since this is 2 at most, that will transfer as 2, at least 2 here and here. So it will be 4 plus 3. Yeah, it's 7. So this is at least 2. And since because of this 3, it's most 2 as well. So it's 2, 1, 3 here, remainder. Okay, so those 2 give us 5. Oh, so combined those 2 are giving us 7, and those will always be 3, means they give, so the remaining part is 4, so this can be only 2, 1, 1, 2 here, 3 remaining here, 1 here, and we have 2. Okay. Okay, let's continue. Next one is over here. So, so we'll need to make some kind of assumptions. Those 2 are combined into 3. That means that this one will be 7 minus 3, 4. So that should produce 4. And it produces double, so it's 2. Nice. Then let's look at some possibilities. This can be 1 or 2. In any case, this 7 will be met. But if this purple one will be 2, it means that this will be 4, and this will be 1, this will be 1. Okay, let's try. If this is 1, then this is 2, and so this is 3, and this is 2 as well. Well, it works. Oh, actually, I think this has 2 solutions. Interesting. So both work. Interesting. Wasn't expecting that. So we have two purple cells which gives us 3, 3. So this is 3, this is 2, this 1. Let's look at blue ones now. Let's make some assumptions. If this one is 3, then it means this combined one supposed to be... Oh yeah, let's start with the lowest one. So if this is 1, then this is supposed to be 6, and so this needs to be 5, which can be. If this is 2, then this is supposed to be 5, and this will be 3. And since it will be 3 and 5, it will be 8, so this will be should remain empty. So this only can be 3. And if this is 3, then it is 4. So 1 over here and 3 here, 2 here. Okay. So the difference here is 4. Oh, and we have 4. And we have 4 over here. That means, okay, what we can say, that this is at least 5. This is at least 5, because if it's lower than 5, then we have more than 6 to put into 2 cells. So this is at least 5. At the same time, this is at most 5 because of the 7. So it's 1, 1, and this is 5 actually. Since it's 5, then we put 3's here. We know this is 5. What do we know next? This is 5, so there's 3, 3, and since it's need to be 5, we have 2, 1 and 1, 1 and 1, and we finish the 9. Let's look at, okay, this cell will be 2 at least, because there's 2 purple cells. That remains as 1 and 1, and this can only be 1s. Nice. This remains 2, 2, 3 over here. We have 3 over here. And okay, let's look at this one. So it's 7. Those 2 supposed to be 6. It's already 2, so we put another 1, and they become 4. So we need another one, 6. 1 remain, 1 and 1. Okay, here we go. So we have 6 and 4 over here. It means that this is supposed to be 2 dots greater than this. So it's 3 and 1 and 3 over here. Let's look at purple cells. This one needs to be 5, and this is the only purple cell left, so this is 1. Since this is 1, this pink or orange combined cells should be 3, and we have this doesn't affect combined, so this is supposed to be 3. 2 to make it 3, so it's 2 left, 2 left. This is 5 already. 1, 3 over here, 3 over here. I think we'll go into more details when we look at the harder complexity. So let's look at this 4. We have at least 1 here, so 4 is complete. What else? This is 2, so this is 2. Great. Okay, and let's look at this 8. It combines 2 accumulated oranges, so they are supposed to be 4 each. That means that it should be 2. We have no more purple, no more orange, so this is 3. Let's see. Let's look at this 10. And we have 4 spent, we have 6, so those should be 3s, and we have 1 yellow left, and it should be combined to 7. We have already 5, so 1, 2 left, 1 left here, 3 left here, 3 left over here, and 1 left. Great. Okay, let's look at this 3 and 5. So it's greater by 2, so it's 3 and 1. And since it's 1, then it's supposed to be 2, which we have 2 cells. Okay, so this is 2, 2. And this orange one has to be 5. Since it's 5, we have 3 remaining, and it needs to be 5 and only 1 orange remaining, so it's 2 over here. We finish with 2. Let's look at this. It's 5, so 2 remains, 2 over here, and no more yellow cells, so this will remain 4. We'll put 2 here, 3 over here. We have 4, 5, 3 left, and finished. Oh, this is actually interesting. You see, we know that there are, in general, as a whole, there are only 4 purple and 5 orange cells, dots in cells. Let's see how we can use that. So we know that this is 5, so 2 remains. What else? What else? So if this is 5, then it's 1 over here. Since this is 4, then 3 over here, 2 left here, and this 4, so this is 2. And this need to be 5, and we have only 1 orange cell left, so this is 3. Okay, we figured this out. So we have 1 left here, we have 1 left here, we have 5 over here, and 7 in total, so only 1s can be applicable here. 2 plus 3, and we finish with 3. Yeah, let's look at the purple one. So we need 3 more dots for purple and only 1 empty cell, so we go 3 over here, and we finish 11. Okay, that's it for main levels. Let's go through more complicated one. I think we finished, yeah, for this section. This is finished. Let's go over here. Okay, we finished those as well. They are green now. Okay, let's do this one. Oh, interesting. So we have 3 yellow and 4 brown ones. What does that mean? Since it's they're combined to 13. Okay, let me take a sip. Okay, so let's say the brown is 3. It'll mean that the brown cells will give us 12, and not enough for yellow cells. Okay, so it's not 3. Let's say that it's 1. If it's 1, then there go 4. We have 7 remaining, and 7 can be divided by 3. So those are 2. We have 4, 8, and we have 5 remaining. Ooh, interesting. Why doesn't it work? So if it's a 1, then we have 4, and we have, oh, actually, so it can't be 3 because it's not enough for those 3 cells. It can't be 2 because this way it will be 8, and we'll have only 5 left, which can be divided among 3. So that means it's 1. So it's 4, 9 remaining. This is 3, and this is 2. Okay, second one. What do we have here? Okay, this blue one, we have multiple, yeah, we have multiple of everything. Okay, blue one can't be 1. It just can't. So it's not 1 because of this 5. Let's see if it can be 3. So if this is 3, so if this is 3, then it will be 2 here, 1 here, 1 here. Okay, let's restart. Let's say it's 1. Oh, it can't be 1. Obviously, it can be only 2 or 3. Let's say it's 2. If this is 2, then this is 2 as well. 2 over here, 3 over here. So those are at least 2, and those are at least 2. Oh, nice. So since this is 8, that means this one is at least 2, which gives this 2 and this 2 and nothing else for this part. That means that our initial assumptions was wrong, so this can be 2. That means it's 3. And now we fill what we have. 2 over here, 1 over here. Great. We still know that this is at least 2. This is at least 2. So 2 or 3. If it is 3, then this one will be 6 plus 2, 8 already. So this is 2. 1 left, 2 left over here, 3 left over here. So it's 5 left for 3. And last one in this section. 3 and 3, 1 here. What else we have? Oh, we have 5 here, so only 1 remaining. So 1 here and 1 here. This is at least 2. This is 4. Oh, maybe let's look at that. This can be 1 because it will be 3 over here and nothing for this cell. Can it be 3? If it's 3, then it can be 3 because of this 3 and can be 1. So it's 2. 2 remains here, 1 here. So 4 here. So oh no 1 1 1. We have 3 left. Okay, we're getting somewhere. Okay, this is 4, right? And this one is at least 2, and this one is at least 2. So 3 remaining. 1 remaining here from this 4. 3 here because of this 6, and 2 because of this 8. We have 3, 5, 6, 2 remaining, and 3 remaining over here, 1 remaining here. Okay, this was the third. Let's go up. Okay, let's look at that. Okay, this is 6, so at most... Okay, let's look at this part. It's 11. So all of those have at least 2 points per cell. And this is 2 at the most. So this is 2, this is 1. And remaining 3 should be 3 per cell, because we need 11 here. Okay. So 9. Okay, let's finish this one. 7. We have 2 remaining. And we have 4 already, and we have 3 empty cells, which is supposed to be 4, and this is 2 at least. So 2 and 1, 1, 3 remaining, 1 remaining, 2 remaining, and 3 remaining over here. This is 6, this is 9, so this is 5. So this cell is at least 2, which with the 4 row we have 1, 1, 2. We have 2 remaining. We have 3 remaining over here, 3 over here, and we finish with this. Next one. We have 5 here and 3 here. So only 2 can be in this cell. Remaining 1, remaining 3, remaining 3. We have 3 here, so it's 9 and 2 remaining. 2 here, 3 here. What else? What else? This is 18, so we have 7, 8, 12, 15. Okay. Okay. This is 5. Okay, 18. 18 is almost depleted, so we have 7, 10, 15. So we have 3 remaining. 3. Only 3. Okay, let's maybe look at this 21. We have 9, 14 already. So we have 7 left. So those 5 cells over here, they store 7. They store 7. Oh, we can observe this. So let's look at this 18 and this 21. What can we say? Oh, let's start maybe with this. Let's say this is, this can't be 1 because it will be 3 over here. Let's say it is 2, so let's put 2 here. If this is 2, then this is 2, this is 1, this is 2. And what we have left? We have 3, 7, 14. 14 here and 2 cells left. And we have 21 as sum. And it can be done. So we have 3, 7, 14. We have 7 left and only 2 cells. That means that this can't be 2. This is supposed to be 3. So this is 1, this is 2, and this is 1. Okay, so and this is correct combination. What we have left? We have 5, 9, 16. So we have 5 left. So both of those are at least 2. That's good to know. And we can finish this 9. We have 5, we have 1, 3 over here, 1 over here. Yeah, that's good progress. Again, let's look at this 21. We have 7, 11, 14, 16. So we have 5 left. That means that this is at least 2. This is at least 2 as well. Okay, so the main point for us is this is at least 2. And let's look at this 12. We have 7, so 5 left, and this is at least 2 as well. So this is 2, this is 2, and this is 1. We have 2 over here, we have 7, 8, 9, we have 3 over here, 1 left. Great. Now what we have here? We have 9, 13, 16, 17, 18, and we finish this. Okay, this one. Let's think. Okay, this is good because we have 5 and 4 cells. So 3 of them are 1s and 1 of them is 2. We'll figure that out. Also we have 5 here. So those 3 cells are combined to 7. Okay. And anything else we can observe? Okay, so let's look at this 7. We have 4, so only 1s for this row, so we have 3 remaining. What else? We have 4, 1, 3 remaining. So this is 3 and 5. Okay, this is 8, it's 5. Okay. For this 16 we have 4, 5, we have 10 already. So we have 10 already over here. So only one of those is 2. Every other one is 1. That's good. Okay, let's look at this from this perspective. Let's look at this cross over here. It's 14 and 14, and this 7 will be counted twice. So every other cell, so those plus those, will be 14, right? So those two combined give 4, and those give 4 as well. So those are 8 in total. That means those 3 cells, those 4 cells actually, should give us 14 minus 8, which is 6, minus this 1, so those should be 5. So those 3 cells will be 5 in total. 5 in total. And those can only be 3 at the most. So at least this is 2. So this one is either 2 or 3. Let's assume that it is 2. So this will be 2. 5 plus 5, we have 2 remaining. Since those will be 3 combined, then the other ones will be 1s. Okay, then this will be 2, and I remind you that our assumption was that this is 2. Okay, what else? So we have 7, 8, 9, we have 2 remaining. Okay, so since it's 2 remaining, it will be like that. 3, 10, 1, 3 here, 1 here, 3 remaining here, 1, 2, 6, 2 remain here, 3, 5, oh, so nothing to put here. which means that our initial assumption that this is 2 was wrong, and this is 3, which makes this 1 and 1. So we'll restart. We'll put this at 3, and this is 1 and 1. Okay. This is supposed to be much simpler now. Yeah, we need to repeat our previous steps, like this is 7, 1, 1, and 1. So this is 3, this is 6 plus 5, 11, 1 here. What else? We have 8 here, so 4 plus 1, we have 3 remaining. What else? What else? We have 7, 8, 9. So we have 5 here. Okay, that's good. So it's 7, 9, we have 5 left. So this is at least 2. But from this standpoint, it's at max 2. So this is 2, this is 1. So we finish this with a 3, we finish this with a 1. 6 here, so 2 remain. Let's finish this 8. We have 4, 2, and 1, so it's 7. We finish with 1. We have 3, we need 2. We finish with 1, 3 remaining. Okay, what we have left? We actually have, like, let's count. We have 6, 7, 8, 12, 14. 14 and 2 remaining, and 2 cells, so 1 and 1. Okay, let's move up. Oh, right here. Okay, so we have 5 and 3 from the get-go. So this is 2, this is 3, and this is 1. That's good. What else? Okay, maybe we can look at those. It can be 3, because it will be 3 and 3, 6, 10, and too much. 2, if it's 2, then it's 4, that's 8, it's 1. It's possible. And if it's 1, then 1, 2, 6, it will be 3. So, okay, no information here yet. Let's look at something else. Oh, okay, this 14, we can fill this up. So it's 6 plus 6, it's 12. So 2 remaining here, 3 remaining here. So we have 9 here and 6 remaining. Oh, actually 6, oh no. We see it here, but it doesn't help us too much yet. So this is 5, 8, we have 6 remaining. What else? Of course, we can make an assumption with one of those and just come to some sort of contradiction. But let's try to figure out a better way. So, okay, let's assume that this is 1. So if this is 1, then it's 4, 6, so 3 remaining. And this is 3, this is 1. So we have 4, 10, 12. So we have 5 over here. 5 over here. And what about that? It's 5, it's 9. So we have 2 over here. Okay, so it's 5, 8, 9. We have 5 remaining for these 2 cells. And we have 6, 7, 10. We have 5 for these 2 cells. So those are 2s. We have now remaining 3 here and remaining 3 here. For this 10, we have 5 plus 6. So our consumption was wrong. Let's try to undo some. No, there's no undo button. Okay, so we just refresh. We assume this is 1. but it can be, and it can be 3 as well, so this is 2. So this is 2, 6, 8, we have 3 over here, and let's start from the beginning. We have 2 here, 2 here. Look at this 5 and 3 again. We have 2, 3, and 1 left. Good. What else? Okay, this 14. We have 6, 7, 12. So this is 2, this is 2, and this is 3. Let's look at this 17. We have 5, 11, 13, so 4 over here. And let's look at that. We have 8, 10, so 4 here. Okay. And here we have 11, here 4 here. That's okay. 5 over here. So 11. Okay, this is 5, 7, and we have 7 left in those cells. Okay, this cell can be 1. If it's 3, then this will be 1 and this will be 2. So if this is 3, then this is 1, this is 2. As a result, those will be like... Okay, let's look at this 14. We have 5, 8, 10. So we have 4 of those. And here we have 5, 6, 7. No, not a good one. And if this is 2, then this is 1. This is 2. This is 1. Okay, let's think. The blue one can be only 1 or 2. Oh, yeah, of course. So, oh, no. Do we need to have some assumption about the blue as well? Or am I missing something? If blue is 1... Okay, let's try it. If blue is 1, then right here we'll have 3. Oh, no. We have 3 here. Right? So this will be 1. And this will be... Oh. Since it's 4, 9, 10, this can be 4. So this can be 1. This can be 3, and this can be 1. So this is actually 2. Nice. So this is 1, remaining 3. This is 5, 11, 12, 3 here, 1 here. And here we have 8, 9. No, this is... Okay, I confused myself. 1 second. Okay, I think I messed up. So if this is 1, then this will be 3, and this... Oh, no. This will be 1, which will read this being like 4, so it can be. So it cannot be 1. So this is 2. And if this is 2, then we have 5, 11, 12. We have... No. This will be 2. Wait a second. Oh, this is 2. I'm sorry. I think I messed up. badly. This should be 2. I need to start over. Unfortunately, I need to start over. I don't remember which one was that. Oh, that's okay. That's not that big of a deal. So we have 2 here. Okay, let's for the change of pace, let's assume that this is 1. This then will be 2 over here, and it'll be 6. So this is 1. This is 2, 3 here, 6, 2 here, 2 here, 3 here. So it will be 10. It will be 10 over here, so at least 2 here, but it can be 3, so it will be 2. 4, 10, 12, 3 here, 1 here. And we have 5, 10, 11, so we have 3 here. We have 5, 6, 9, we have 1 here. We have 4 and 4, we have 1 left. We have 2 left here, 2 here. What else? We have 3, 9, 11. 11, so 3 here, and 1 here. And we're done. Good. We rectified this mistake, at least. Okay. So let's look at this row. We have 11 and 4 cells. So only one of those can be 2. And because of this 3, this is the cell. Others will be 3. What else can we tell? So we have 3, of course. This is 1. Okay, let's look at this 4. Only one of those can be 2. And because of this 5, this is 2. So this is 1 and 1. 3 remaining here. Because of this 6, and we already have 4, only 1 remaining here. We have 4 here, 3 remaining here. Yeah, it's a good start. So we have 9 here and 4 already filled, so we have 5 for those 2 cells. So this is at least 2. So this one is at most 2. Okay, so this plus this equals 4. And this plus this equals 5. So this one is greater than this one by 1. And we have like 6 already, and those 3 give us 6 in total. Since this one is greater than this one by 1, it means that this one is even. No, it's odd. It can be only 1 of 3. 1 of 3. If it's yeah, it can be 1 of 3. Okay, so 1 of 3. Since then it means that these are 5 in total. Oh, no, not necessarily. Okay, I think that we can look at this from another angle. So let's say this is 1. Okay, no, this is 6, so combined those give 4. If this is 1, then it will mean that this is 3. And this will be 1, 2, this will be 4, so it can be 1. What if it's 2? If it's 2, then this is 2 as well. and this will be 3. So 2, 3, 4, so yeah, 3. So this is 2 and 3, 5, plus 3, 8, 11. So this will be 1. Yeah, this can work. And what if this is 3? If this is 3, then this will be 2, and this will be 1. So 3, 6, 9, it works as well. Okay, so no clue for this one. That's okay, that's fine. That is fine. Okay, so we know the total for 4. Okay, we need to look at something else. Like let's look at this 10. We have 2 already, so at least 2 in those cells. But we have 3 over here, so it is 2, and those are 3 and 3. So this is 1, and this is 1. So we have here 6 and 6 remaining. So this is 3, 1 left, 1 left. 1 left over here. So we have 5, 1 left. For this 12, we have 4, 8, 9, 12. We have 1 left. Yeah, sometimes you just need to change the perspective and look somewhere else. Maybe we could have figured out from this angle, but still. Okay, this is a bigger one. What we have here? We have 11 here, so only 1 missing. What else we can deduct? We have 14 here, so only 1 missing as well. This is okay. This is 12, and we already have 7. So 5 for those 2. So this is 2. This is 1. This is 3. What else? So this is 10, and we have already 2. So at least 2 for those. Oh, let's shift. Let's finish this one. 2 and 1. We have 4. We have 1 left. This is good. And we have 3 here. So at least 2 here and here and here. Oh, interestingly, we have 6 cells here, and they're combined into 11. And we have 14 here. Oh, let's look at this row. We have 10, 4 already present, so 6 for the 5 remaining. So only one of them can be 2. But from here we know that this is at least 2. So this will be 2, 6, and we fill it with 10. We have 5, we complete this. This is 3. What else do we know? This is 3 and 1, so 1 remaining. We have 8, 4 remaining. Let's look at this 10. We have 3, 6, 7, 3 remaining. For this 8 we have 7, 1. For this 13 we have 6, 10, so 3 remaining. So 2 remaining. Okay, let's look at this 14. We have 5, 8, 11. Almost done with this left one. So it's 3, 9, 10, 2 remaining. And 4, 8, 10, 1 remaining. Great. So the one on the left is finished, which actually brings only this as 3, which we had already. So it's kind of isolated puzzle right here. What do we know about this? We know what we know. Actually, we know that combined Okay, so we know that those give us 24 in total. So those are 24 in total. On the other hand, those are 24 in total as well. So we have 17, 24. So those are 24 in total. And those are 24 in total. And what is different between them? So it means that those two cells have the same value, because all of those are equal in those two sets. So this is 24, so this part plus this, and this is 24 as well. So this plus this cell, so those are equal. Those are equal. So can they be 1? No, because it will be only 4 and we have 6. Can they be 2? No, we'll have 4 here, so they are 3. We should leave this cell to be 2. This will remain 3. We have 6, so we've finished this 14. Come on, 1. And we finish. Okay, let's move up. Up, up, up. Up we go. Okay, so what we have over here? We have 3 here. Okay, let's look at this 14. We have 6, we have 10. So combine those give us 2. But at the same time, since they are equal, those two equal those two, and they are 14, then each of those should be 7. So this is 1 and this is 3. That's good. So let's look at this 5. It should be either 2 or 3, because it needs to be more than 1, but it can be 3 because we'll have only 2 left for these 3 cells. So it is 2 and 1's over here. What else? I think it's time to look at the bottom. Let's say this is 1. If this is 1, then this needs to be 3. And since this and this is at least 2 because of those 5's, then it will be 2 plus 3 plus 2, which is already 7. And there is no spots, no numbers left for this cell. So this is not 1. So this is 2 and this is 1. Great. So this is 2 or 3. So it can be 1 because we need to be more than 3. What else? What else can we say? So this is 2 or 3. Let's if it's 3, then we have 4 and we have only 3 left for those 2 cells, which is not enough because there are at least 2. So this is 2. So we have 3. This is 2, 2, and 3 remaining. Next one. Okay, we have something greater than something, which equals this. Okay. Okay, we have 3 here, so this is only 1 or 2. And since this is greater than this, it can't be 1. So this is 2. This is 1. And this is 1 because something needs to be greater than less than 2. So this is 1, this is 1. Since it's 7, then it's 3 and 3. Since it's 9 and we have 3 already, we put 3 here, 1 here remaining, 3 equals 3. For this 6 we have 1, 2, 5, 1 left, 3 and 3. Yeah, much easier. And we have third one. For this third one we have one cell that is greater than 2 cells, which means that it's 1, 1 and 2. We have 2 remaining here, 3 remaining here, 1 remaining here. Again, we have one cell greater than 2 cells, and it's 1, and this is 3. And let's look at this 8. We have all that row equal to 8, which means that this equals 4, which leaves us only 1. We fill up this 2. And this is 4 as well, actually. Let's look at this 4. We have 2 remaining. Let's look at this row. It's 4, 7, 8, 10, 13. 4, 7, 8, 10, 13. So this is supposed to be 4. How did that happen? How did that happen? I guess I made a mistake somewhere. So it's 4, 7, 8, 10, 13. Okay, no big deal. Let's just restart. It will be easier to just restart, not to look the error somewhere. So let's start. This one is greater than those 2 cells, so it's 1 and 1, and this is 3. Good. That means that this is 3, and what we know for sure, this one is greater than those 2, so 1, 1 and 3 here, 3 here, 2 here. Okay, we still know that 3 plus 1, 4, we have 2 remaining here, so 2 is here, we have 1 here, 2 here, so we have 3, 5, 8, 9, 11, 14. So we have 3 over here. We have 2 here. I wonder when I got a mistake previously. Okay, so this needs to be 4 because we have 4, 6, so it's 2 remaining. So we have 3 over here and 2 over here. Oh, we have another 8, so it's 3 and 3. Okay, let's move up. Okay, so 3 final puzzles. So this one. Well, okay, let's look at those purple ones. Since this is at least 1 and this is at least 1 as well, this can't be 3, because if it's 3 then it's already more than 4. Okay, if it's 2 then it is 4, and this becomes empty, so this is 1, and to complete it to 4 we need to put here 2, and we have 4, and of course 8 because it relies only on purple. So finished purple. From that we know that combined orange give us 5, so we have only 1 orange left, so this is 3. We complete this, we complete this and this. We have 6, 1 left, 2 left here, 2 left over here, 1 left over here. What else? We have 5 in these 2 cells, but maximum of 2 here, so it's 2, 3 here, 1 here, 1, 1 and 3 here. Good stuff. Let's look at yellow ones. Since like yellow supposed to have at least one dot, so it will be 1 and 1, and we just finished 3. They can be greater than that, so we complete this with 3. So it's 4. So those 4 cells have 11 in total. And since it's 3 here, it can be 3 in this cell alone. So it will be 2 and others will be 3. So 1 remains here. Let's look at this row now. No, because of this purple, it can be as high as 6, so it won't be easy to calculate. So we have 4 here, 2 remaining. We have 3 remaining over here. What next? So those are 5. Okay, let's look at that. Let's look at this 12. Since we have 3 and maximum for this cell is 3, then this cell is supposed to be at least 6. And we have only 2 purple cells, so both of them supposed to be 3. And we're done with purple. So it's 9, we have 3 here, 1 left, 4 here, 1 left. Nice. So since purple here is filled, it will give 9. So this orange will be 4. So this will be 4 plus 6, 10. We have 2. But orange is supposed to have 4 in total. So 2 goes here, and we have 3 remaining here. Nice. Let's look at the remaining row. So we have 7, 10. So 1 and 1. Okay, let's do that. What we can see over here. Something. Those two give 10 in total. It's quite high actually. It's quite big of a number. Yeah, I think we need to use that. Okay, let's look at this 8. Since this is at maximum, this is 3. So this yellow one is at least 5. It's at least 5. And since it's at least 5, then it needs to be at least 1, which makes it actually 5. So if this 5, then the red one is also 5. Okay, so we know that both yellow and red are combined to 5. That's good to know. Since this is 5, then this is 3, this is 2, and this is 2. But we know that red gives us 5 in total, so this is 3. Okay, nice. So we know this is 5, this is 3. Good, very good. What else? We know that yellow gives us 5 in total. So this is 5. What else can we say? Oh, this is 2 because of this 4. And we know that this is 5. By the way, it's 5, 8, 12. So what else can we deduce? Let's actually look at this 9. Because it's kind of connected. We have only one purple cell left. So let's say let's say this is 1, then it will be 4, so this will need to be 3, and this will be 2. 2 plus 1 is 3. I think there is a good thing, but it's kind of okay. Let's look at this 5 maybe. This is at least 2, and this is at least 2 as well. So if it's at least 2 and this is 11. Okay, so what can we say about orange actually? So combined orange is at least 5, because it can be 6 over here, and so it needs to be at least 5, which means that if this is 2, yeah, this still can be 5, and it will be 2 plus 5. Oh, if this is 2, then it will be maximum of 5, it will be 7, so it can't be 2, so this is 3. Good, so this is 2. And for this to work, what else? We know this for sure, but we don't know what exactly this can be. If it's 2, then it will be, yeah, it can be 2. It absolutely can. Okay. So we know that this is 2 at least, this is 2 at least. So this is 8. Okay, so let's work with this cell. It can be 1. It can be only 2 or 3. Let's say it is 3. Okay, that's 3. That means that this will be 1. So we'll have 4 plus 6, 10, and this needs to be 5 in total. 5 in total. So if this is 5 in total, then we have to put 2 here. Oh, okay, so this will be 5 in total, so we'll have to put 2 right here, and this will make it 3, and it's too much, it's 12 already. So this is not 2, and this is not 3, so this is 2 actually. Since it's 2, then this is 2 as well. What we have here, we have 5 and 5, 10, and we have right here. Okay, we finished this 15, this is 8, 3 remaining, we have 5 here, and no more purples, we have 2 here, we have 6, 2 remaining, 3 remaining, we have 2 remaining over here, still have figure out how to get this to 5, but that's okay. Oh, actually we have 5, 10, 14, so we know this is 2. And since it's an 8, so we know that this is 3 and this is 3. And we need this to be 5, with 1 remaining yellow. This is 2 and this is 3. Let's look at this 14. We have 5, 8, 10, 13, 14. For this 10 we have 9, 1 left. For this 16 we have 3, 8, 10, 13, we have 3 remaining. And for this 24 we have 7, 10, 15, 21, so 3 remaining, and 1 remaining over here. And that's about it for basic complexity, for the green complexity of the game. Thank you for watching this video. I think we'll have a more in-depth discussion on hard version, because it doesn't have actually the levels are different there, and it doesn't give you hints, so it only finishes when you're done. So we'll get back to that. Okay, thank you everybody, goodbye.